Okay, I'm Filipe Salbany, obviously. No fancy slides or data, because I think I speak for myself. I think with Matt as well, a lot of our lives have been about being out in the field, being out in the countryside, working with with local people, and seeing what's out there. And we'll talk about Blenheim, but there's a huge degradation of the landscape. We're a very needy species, and we're losing a lot. And to put it into context, there are about 6,500 languages spoken in the world, and we're losing about 50% of languages. And with that, we're losing all the emotion, the context, and the local knowledge. So it really comes back to that. It's what are our observations when we are out in the field, and how do we allow species to be themselves? Bee honeybees have got huge recombination rates. Recombination are really quick in honeybees, and so their adaptation to specific environments can occur very, very quickly. And there's a chap called Jeff Tribe, who's a professor emeritus in South Africa, and he just talks, the best bee for an area is your local bee. And there's another chap called Needham, and he wrote that the best bee for a local site is the local bee. So it all comes back to what we've been talking about with this. But I talk too much, so I'll just pass you on to Matt, and then we'll just, I'd like to be here for a long time.
Yeah, hi. So Filipe and I there's quite a bit of crossover between us, because for the last, 15 years or so, or Filipe's case probably longer, and working in Africa, we've been studying just breeding bees and wild bees. And what's really interesting is that, yes, I think you're interested in survival rates and all that kind of thing, but that's just the tip of the iceberg about this bee. And I think we look at bees in hives, and we know we've done our research on that, but no one's really looking at what bees are like inside a hive and how they organise themselves, and how vital propolis is to bee health. And yes, you can look in and you can take samples of DNA, but you can't necessarily see their comb structure. And we take for granted that perhaps that bees build in straight leaves that we can dissect, but actually they don't. Quite often they might start going down in one way and they mix, and you'll get in a cavity these huge dead ends, which are great reservoirs for heat retention. And thermodynamically, of course, a big square box with a thin wall is hopeless for a bee, and in terms of the amount of energy loss. So in looking at wild colonies, we don't just go in 3 or 4 times a year. We're constantly, if not daily or certainly weekly, going around looking at bee behaviour. And so, for instance, at this time of year, we're seeing scouts, perhaps 2 or 3 weeks before the swarm season, looking at nests and how scouts from different colonies interact with each other, sometimes killing each other. And there's just all this world going on. And then because we're not taking honey, there's not that pressure on those bees to keep on producing bees and keep on foraging. And so quite often, they might even, if they're lucky, inherit a nest that already has great honey stores in it. So the actual amount of work those bees are having to do is much less than you would see. So we're looking at wild nests. We're not looking for great streams of bees flowing out there. We might just see them dribbling, and that's not a sign of your colony is weak. That's just all they need to do. And especially in the summer, we see the colonies reduce in activity, and one of the key things they're doing is producing this. I don't know whether you can see that. You won't be able to see it on Zoom, but these are entrances. On the hives I have 3 holes. One's about a bit over 2/3, and we noticed that the bees they want to deposit their pollen or nectar quick as they can, so they can get out, and all the receptive bees will be on the honey, ready to take it out. So we give them a choice of a lower hole where they could walk up to the combs, but they don't want to do that. Over all the hundreds of hives I put up, people in France put up, people out in the States put up, they all like to deposit. The workers go up higher up, and then the bees down the bottom will be fanning. So getting rid of all the the moist air and carbon dioxide. And but what's extraordinary is the amount. You can see these are top entrances, or top in the middle. That's where it is, I think. Those aren't. They're not blocking off because they don't use them. They're bringing in propolis, and there's huge propolis dumps. You can see on the edge, I think. You can see it dripping down here. It's a major consideration that the bees are bringing in, and that happens in the summer months. So if you're stealing the honey in July, whenever I don't know what we do now, but June, July, those bees are suddenly going to have to go out and work, and maybe they're going to have to go and work bringing in ivy honey. With the wild commons, we don't see that. So we don't see that huge autumn rush to get ivy. So consequently, we're not getting unfermented honey in the nest, or it going thick, whatever you call it. So I think we've got to really think about free living bees as a different beast. It's like Jane Goodall looking at chimps in a zoo and then going out to Africa. It's totally, even though they might be genetically similar, the way they live is totally different. And there's endless things that when they go in, when they festoon, they don't festoon in chains that you might see in our beehives and then go, that's what festoon. They festoon like an upside down Eiffel Tower, like a matrix. So the behaviour, given that space, they behave differently. And I think for your research, John, it's important to just get more than just thinking about size of cavity, which Seeley's been doing 20, 30 years ago, but just move into these other things of observation and how perhaps we can, ultimately at the end, how are we going to change the way we keep bees? Are we going to insulate them more? Are we going to look at them less and not interfere and put that stress? These are key fundamental things that we've learned from our years of climbing trees and looking at bees.
And the thing is, we get caught in dogma. Okay, so we've come up with beehives that have been around for 170 years. Prokopowicz in about 1810, but it's probably the time that that Varroa jumped species from Serrano to Mellifera in the Primorsky region in Russia. But the beehives have been around, 1854, so something like that, with the Langstroth hive, and then foundation in about 1880. And then we give it a defined size, 5.3 millimeters, whatever cell. But with the bees, when you watch them a long time, these free living colonies, we find that they tend to become more homogeneous. So they do become darker. They lose the banding. And we can see this even over 2 years, 18 months to 2 years. And we see is a much smaller bee developing over the years. Now, honeybee queens, we used to see honeybee queens marked living 4 years, 5 years in South Africa and Zimbabwe. And we were quite into looking at honeybee queens because it's a really sort of interesting situation where I actually knew Mr. Schnettler, who famously gave some honeybee queens to Professor Kerr that became the Africanized bees in Brazil. Okay, that escaped in 1856. Not that I was born in the 1850s, but in 1950s. But there was a huge queen emphasis on producing less defensive scutellata bees in Africa. And so we've got this looking at queens and how long queens live, and then also not changing combs. So the bees molt, the cells get smaller and smaller and smaller, and we're going from the scutellata smaller for about 4.95 millimeters, but we're going right down to about 4.4, 4.5. So there's actually research that the bees can go down about 50% drop in size. Okay, on old combs. So we keep changing combs. You're changing the honeybee. What changes if you change the size of the honeybee?
Keep warm.
The proboscis, the tongue changes. Okay, so your pollination, the nectar, the nectar challenges, or where the bee goes, starts to change. They start to adapt even more and more to the environment. And if you think that this is far-fetched, that I'm making this up, we've got a bee in the Drakensberg called the kranzbee. Again, the kranzbee is this dark bee, and it's tiny. Okay, and the cells are about 4.2, 4.3 millimeters. And so there's these bees are now living on really, really old comb. And back home, even though I live here, but Portugal, I've climbed in Portugal, I've climbed in the United States, climbed obviously in South Africa, looked in caves, okay, and I've spoken to Matt, so we sort of compare. I have yet to find a wax moth up there, Melanella, lesser and greater wax moth, but only the moths, not what we call it, the web that you find in beehives. So is that a human construct? We're not finding it in nature, okay? And when we've got smaller holes and we've got entrances in trees, these are much bigger cracks or the holes. I mean, a black woodpecker, the primary excavator of trees. So as Ollie, was talking about, the size of the entrance, 10 centimeters. Yeah, it's a pretty good size, but it creates a volume of about 16 to 20 liters. Is that right? Okay, so we're talking about the size of a super. I've just been to an estate where they've got 2 swarms that they caught. Okay, pretty dark bees, whether it means anything, just, they've survived, caught in July, and they've overwintered on supers. So there's some really important things that we've got to look at, and we've got to recognize that bees are capable of evolving themselves. We just have to look at the Cuban situation, Carlos de Noronha, where they stopped imports, if they allowed the bees to, no movement of bees around, they became varroa tolerant populations. Africa is the same. It took about 5 to 6 years for Scutellata, Leutherea, Monticula, etc. to become varroa tolerant. That's over the whole continent. So bees can do that. There's a chap in the United States called Steve Tabor. Anybody heard of Steve Tabor? Yeah, fantastic. And he developed there's a strain of bees tolerant, not showing the symptoms of American and European foul breed. So by having places that are secluded, that are isolated, like Scilly, or if you were to take sections of Britain and be able to get the people together and start forming a consensus, okay, so what are we going to keep, what are we going to help nature with? So whether it's Norfolk, or whether it's part of Cornwall, or whether it's some of these isolated places in Wales, okay, we can develop pockets of resilient populations of honeybees. And what do we do with those? We do not move them around. Even your very, very local bees, even moving them to a quarantine apiary or what, all this nonsense, all this stuff, even 10 kilometers might be too much for these very locally adapted bees. So we've got to really look and understand what is there, get involved and looking at the colonies, and then look at what's happening in the countryside. The biggest lesson from Blenheim and from these other estates that Matt and I work with, that I have seen, is an erosion of knowledge.
Yeah, and that goes another part of what we do is education is key, and the key people who are interested are kids. The key thing, looking at the audience here, I don't know what the average age is, but there aren't any children here, or there aren't any children, young people, adults in their 20s even, and I think we've got to inspire kids at 5 or below to just have an interest in nature. And the bee is like the panda or the koala bear or the whale. It's just that entry point that, it's in the landscape lots of times, so people can go and see that rhythm, which is exciting, and learn to connect with pollens, and colour pollens coming in. But it's just, that seems to be the key, most important thing. And free living bees work really well with that. And I go, kids already, they've read Winnie the Pooh, and then suddenly, a few years later, they think beekeeping is all about in boxes. And I think there's an opportunity I work with about 4 schools where we actually make the hives with the children. So 9-year-olds are using a gouge, and they get involved. And then when they see something that they made, bees come. They're in tears. They're overjoyed, and they're out there looking at those bees every day. And one school I worked in, Norfolk, I was there putting up a rocket hive. It's one of these hives on lakes that I made. They were there 8 hours, I was there 7 hours, and constantly putting up hands. And then by the end of the day, they formed a bee club. They were looking at flowers, and it's just, that's the kind of thing I think that is so vital that we need to do. Just as we're losing our veteran trees, we're losing our David Attenboroughs and our Chris Pattons. Who are these people in the future? So, Yeah, log house. We go and work on estates where we get the farmers involved making the logs, and we have a chat about it. And then now they're putting them up, and they're going out looking for scouts. And that's the kind of thing what we want. And then they're working together as estates, which is not only good for bees, but they're starting thinking about ponds, working together as farmers. And I think that's the key thing.
Yesterday we were at Andrew Brown's place, and I was monkeying around in a tree. But Matt and I, we looked at this tree and thought, oh, you know, there's something about this tree that's just different, okay? And we put up a log, and I was up there. We took a picture of some flower of the flower, which is incredibly rare to get a flower of this tree at this time of the year. Okay, not only is it a rare species of elm, so it's an elm, but it's even rarer because it's the Cornish elm, Ulmus stricta, Ulmus.
I can remember.
It's Ulmus stricta. Okay,
Yeah.
It's the Cornish elm. It is extremely rare. Okay, and so, you know, we've got to be looking at things. It's not just about the honeybee, it's about the context of the whole environment. Britain has lost, I mean, elm trees, there were 22. You guys will know, how many elm trees were there? How many elm trees? There were 20 to 25 million elm trees. Elm trees had massive amount of cavities. You said something, it's about, they had the acid is different to the oak trees with tannin. 2 to 3 cavities per elm tree. 20 million elms in the last 50 years. Ash trees. Anybody seen how many ash trees have come down? Okay, they're, whatever, 120, 130 million ash trees. About 80% of those are coming down.
Many with cavities.
Many with cavities. We're talking, you know, now in the area around Oxfordshire, we've got parakeets. There are parakeets at Whiteham, the most studied wood, you know, in Britain. We've got parakeets at Blenheim and in other estates. There is competition for cavities. How do we know that 40, 50 years ago that the bees finding these ideal cavities, okay, that those are the ones that we've lost? You see, when I was running around in, you know, one of the biomes, you know, the Fynbos region in South Africa, barefoot on the rocks, you know, in the Cape Peninsula, and finding these bees, you know, underneath rocks and etc. And you just find them, and then, you know, inevitably you go and stick your hand in it, and then you run a mile because they're pretty defensive. They're just windswept along there with all the proteas and all this. It's fantastic. But there is an indigenous knowledge there. That when you go out, you know, I was talking to Derek, when you're looking at the sand people, and they're out in the Okavango, in some of the areas, okay, apart from people telling you where the landmines are, okay, so you don't go and put your foot on it. But these people that can find the honeybees in termite nests, in trees, in what, I mean, I found one in a T-54 bombed out tank, you know, in Chimoio, in the Gorongosa region. And, you know, it's that local indigenous knowledge. We need to be getting that back. If we just follow the doctrine, and the whole thing is, or, you know, people go and they get the phones, okay, and it's just like, oh yeah, you go and search. No, we've got to be observing. It may be, if you can come and look at these things over here, that maybe the most important thing for honeybees living in freedom is actually propolis.
Yeah, this whole inside here is, it's a rotten beech tree that it's had a lot of beetle attack, and actually it was totally red with propolis, and it's up, you know, it feels like a tough skin, and without that, the comb, you know, this tree would not be able to support that colony. So the bees, another importance is giving this kind of internal structure. But yeah, I mean, we could pass this around, but have a look at it. You know, the insides of the hives, they're just bright. There's no condensation and mould. I think it's a vital trip that we're missing with our bees.
So we can talk forever, but you know, that gives us, you know, like for the first time ever, I think, like really good time for people to ask, you know, some questions, and you know, if the things that you'd like to, you know, us to follow up on, or yeah, just feel free. Oh, by the way, for call it serendipity or whatever, but Jonathan very kindly mentioned my name, talking about your different bees, and so here's your mountain bike, here's your cross bike, and here's your racing bike. These things happen, So we talk a lot about in Africa that there's a connection with the honeybees and the spirits of the ancestors. Okay, and 2 days ago my uncle died, and today I'm here, finding an elm tree yesterday with Matt at Andrew's house, and talking about bees. Whether there's a swarm or not, there's that connection, with nature. I mean, what it did for me to be up on that elm tree, something that's so unique and so precious for the environment, is worth more than anything. And these are the treasures that we've got in the landscape, and it's our duty, it's our responsibility that we leave a legacy for future generations. If we don't look after the landscape, if we don't look after these wild populations, we're going to lose it for the future generations.
Philip and Matt, thanks ever so much for that. I grew up in Kent, as a man of Kent and a boy of Kent, and we were taught to look in forests for anything like that. But your observation about where are the young people, I think is very true. I've got 2 grown-up children now, and they asked me, Dad, what's the difference between a wild bee and a free-living bee? And they did not get the terminology. When I was a boy, they were wild bees.
Yeah.
So I'm just looking now, perhaps we've gone a stage too far. What is a wild bee? Why are they free-living bees? What's the difference? To attract that attention, maybe just stick to, and it's also confusing when a wild bee is compared to a free-living bee on the same page in a National Bee magazine when they're talking about the same bees. So perhaps we've gone too far in terminology.
I absolutely agree. I think that what a free-living bee is what excites kids, or what excited me as a kid, was finding that cavity in a tree, purple staying around the outside of the metropolis, and bees are coming year after year. I've seen bees. I've got one colony here. My oldest has been there. I look at it every winter. It's been there like 15 years now. And to me, they're free-living, they're wild bees. I think free-living is a sort of political thing that's come in the last few years, because people don't, there's a wild and feral, but they're wild.
That's my point. When I was a child, they were wild. My children grew up known as wild bees.
Yeah.
When did we change them to free-living? Children don't get that.
I grew up in Kent, and I was putting a spoon on a stick, chucking in the hole, thinking I was going to get some honey, and then got badly stung. But that's where that whole love comes from. And we were looking at we were looking at birds' nests as well. We all got that sort of age, and that's what I think. I think the bees can engage kids, and I think you were asking about what you do with this project in South West. I think you need to go into schools and talk to kids and excite them about that. And this whole mystery and magic of bees going into a tree is a great way to engage them.
Do you think there's not a free play outside? You said you put a spoon on the stick and shot outside the tree.
Well, I think when I was a kid, I was bored, so we were kicked out of the house, so we were at unrestricted play and did silly things. But we were curious, just that curiosity. I think we can all talk about nature, but it's just that curiosity to be constantly looking for something. I've got an apprentice he's 20, he's going to university. He has no idea what any tree species will ever be, because he didn't know what a primrose was, he didn't know what a bluebell was, he didn't know what a kingfish was, he didn't know what a robin was. And this is really, brings me to tears. And how can they look after the whole world when they have no idea what's out there? And that's pretty shocking. He's not alone. He says, well, that's what everyone's like. People on his phone. But, So I think we've got a duty to educate and excite kids.
I have to say, I've just signed up to do some educational tours on the farm, and I'm kind of okay with doing adults, but once you get into taking children around, boy, the insurance company was farm. I had to fill in, and that's the great health and safety thing. I had to, I mean, probably everybody knows it. It's just.
There are courageous teachers who do that, and I've been to schools where the headmistress, the children are growing vegetables in their school. They understand the whole food comes from the vegetable, a local farm. They're realising those risks are worth working out because of the value to those kids. And I've never seen so many engaged kids in my life.
And maybe that's our responsibility. We need to think about actual education. And if the bees, I'm not giving it any, acronym, not so adjective, wild or free or free living. These are just bees. Maybe the other way is that they aren't domesticated bees. We just got bees in beehives. I mean, we don't sort of go, come here and but that's the thing. It's up in the trees or in walls, whatever. It's getting the children or young people just to have a look. I'm sure all of you, or most of you, have seen a swarm arrive. It's magical. And so if we can talk about that, explain that, and get people to be out and recognizing it and looking for these things, and then leading to colonies and cavities, finding these populations.
Yeah, and free-living bees aren't, not on the ground, they're up high, they're out. So from a safety point of view, it works well. That elm tree you'll be able to take kids to and look up and see bees, and they'll go, well, how do you get the honey? And you'll go, well, actually, bees weren't evolved just for us, for honey. They've got a bigger purpose. And then suddenly, they're engaged. Anyway, that's what I'm finding. I just think it'd be great if your projects you're doing here is encourages kids to go out looking and enjoying it.
The highest nest we've got is 25 meters. It's a fantastic climb. It's my favorite thing, and just sort of sit up there. And these bees and I found this in Africa as well. Once you put up these nests, hanging them up in the trees and the woven baskets, etc., they're not defensive. It's just when they're sort of on the ground. So there's a difference that happens up there. But no bee suits, no gloves. I've yet to be stung up in a tree in the last 4 or 5 years.
Holly, I think if you can do a climbing course, it'd be fantastic to sit up on a branch next to a colony going in, and then you're just like you say, just sitting there. They suddenly they're aware of the presence of another human, and they'll start sensing, showing the other bees the direction to come back. And all these little subtle things are so interesting to see.
Why do you think you've not been stung up in a tree versus if you're down by a hive, you may well be?
I think there are different stresses, and a really important aspect of being up in a nest with a tree is that you change. Bees are very good at, if you want to keep bees in a line, you get a lot of drifting of forages. But you can negate that to an extent by putting three-dimensional objects in front of the hive. So you can put stones, pieces of wood, etc. So when you're up in the tree, you immediately change the 3D configuration in front of the nest entrance. So they recognize that something's different. So you're getting these bees just landing on you, and they all start fanning as if they've lost the nest. Now, to put that on the other side, we had a beech tree that fell down, 10 meters snapped down. Okay, this was in November, I think. It snapped out. Not a single bee went back from the ground, back up to that place where they were before. They all stayed on the ground. They've actually survived. I put them in a box with cork inside and a top. They've survived. But there's something that happens there. But with up there, it's just us changing, the whole structure of the tree that they've just become accustomed to. So yeah.
Another question, because in the free-living bee, the same comb is using year after year, and obviously the cells become smaller and smaller, as mentioned, and the size of the bee are smaller as well. How it looks if you count the bigger cells are preferred for drones? Is it change the structure of the colony?
Sorry.
The structure of the colony, how many drones and how many workers? Is it?
I don't know. The drones, it's thought that they need a lower temperature. Okay.
Yeah, but it's more about the laying eggs and drone eggs.
Exactly. Yeah. Okay. Now, Matt dissected one of these colonies in a nest, and the drone comb, no drone comb anywhere except right down the middle.
Okay.
Okay, so completely different to what we find in a beehive. Okay, or you find in a lot of the nests. So maybe that is a way to actually start looking at some adaptation that there is with bees moving from the ground or being from a managed environment up into the trees. Now, in terms of the characteristics of the drones, and then this is something that applies a lot to the genetic work that that sort of happens and how we sort of might move some genetics around and things like that. We then get into some sort of discussions into apiary vicinity mating, for example, drones flying at different temperatures, etc. So it brings that into context. Okay, is the queen then pre-selecting the eggs that she's laying, the unfertilized eggs? Is there some selection there? I don't know, and I don't think we do know, but I just think there's a structure.
Of course, we cannot know that, but if the try to imagine the size of the cavity is so restricted, because it's so it is, and you cannot put another wood box, there is no place to build a separate comb for the drones.
But the bees can chew the comb.
Oh, yeah.
They can chew it, and bees have got fantastic mandibles.
Yeah.
Okay, so they will within this, and they're excavating this. It's like a dentist going in with a drill and getting all the. I've got to be careful with using my Afrikaans here, but they'll excavate the rot out, and then they put propolis on it. Okay, and so they chew that, and that's been completely chewed. That was okay, and so they can chew the comb. They can select. They don't have to fly the whole time to getting honey out, to getting nectar. So they've got other duties that they can do, which is layering propolis, chewing comb, building new comb specific for an area. And it may be, now this gets really funky, the swarm season doesn't start straight away in February or March. You've still got your older winter bees and you've got your central brood, let's say, on the smaller combs that have been used year after year. Then they start to expand out. Okay, come March, April, it's getting warmer. Yeah, so you've got the temperature regulation, the bees are moving out. They're now moving into cells that have not had so many pupae in. The cells are getting bigger. Yeah, make sense? So then we're getting, this is funky, isn't it? Okay, we're now getting to April, May. You're now getting towards the outside of the cells. The queen selects, this is known, the queen selects the daughter eggs that she wants to lay. They're genetically similar to the queen. They know the area, the local area that they are living in. But also when she swarms, those bees are bigger. So all of a sudden, they can get to other nectar sources that the original nest is now not using, because their primary goal is then, if they have to use, if they tend to go for a nest where they've got old wax, okay? If they have to, they can produce comb, which is, the African bee, for example, is renowned for producing comb. The empires, they literally raped Africa, the honeybees, for getting beeswax. So these bees are bigger, they can go and forage on different plants, they can fly further, they are stronger, okay? And will outcompete other pollinators. And so they can harvest more and rebuild comb structures if needed. So there's a really interesting, interesting thing in terms of of the size of the honeybee and the structure, the history of the comb.
I'm going to ask you that if you want to hear more from these two amazing chaps, both Matt and Philippe there's quite a lot of them on YouTube, there's quite a few films to, yes, I've seen them.